Alright, welcome back for Chapter 1, Section 3, Slope Fields and Solution Curves. So, what this section of Chapter 1 deals with is really your first new exposure to a solution method for first-order ordinary differential equations. So, let's get started. Alright, so you have a differential equation of this form, and right here where you have both independent variables and dependent variables in the right-hand side of the equation. So we can't use our integral method that we've talked about before, so we have to come up with another one. So here's the first question I'm going to ask you. Is when you take a derivative of a function, what information does it provide about that function? Alright, it gives you the slope of that function at a particular point, or a particular x and y value. Alright, so what we're going to do is, since we know the slope of our solution curve at every x and y point, we're going to make a graph and graph the slope at every point of interest in the xy plane. So to do this, it's much more efficient to use some software. Some calculators might do this, but we also have access to Maple, and it'll create what is referred to as a slope field plot, or sometimes referred to as a direction field plot. So to get this command to work, to get direction fields to work for you, the first thing you have to do is the width capital DE tools command. So I don't think this W in the width, capital W in the width, is important. It's just width, parentheses, then you need capital D, capital E, tools, close parentheses, colon, and then hit return. Right. Then you can call this routine called DE plot, and again you need the capital D and E in there. Then the first thing you want to give it is the differential equation, and you can use the palettes to put that in there. Then a comma, you want to tell it the dependent variable and what it's dependent and what it's dependent on, x, and then you don't have to give it you have to give it a range for x values and y values, and I've just defaulted to -10 to 10 to see what it looks like, but then once you've plotted it out, you can get it to show up. So what does slope field or direction field look like? It kind of looks like this. So here's our differential equation. The derivative of y equals minus 0.4 times the square root of y. Now you notice I have y of x here and y of x here. Maple likes to know that the dependent variables depend on the independent variables. So you always have to type it into Maple as a y of x. If not, it's not going to know y is dependent on x. So what the DE plot command does is plot this graph, and you'll notice it doesn't plot anything in the negative y-axis because you can't get a negative number out of the square root function. But you notice that all these lines here, these arrows, that's the slope at a particular point. Alright, so how do we use this to get a solution? Well, we have to take a solution at a particular point. Now I am tried to select here x equals 3, y equals 4, and I'm going to say that our solution curve has to pass through this point. Now to do that, I have to draw a curve that maintains the slope that the slope fields tell us. So, and in between this arrow and this arrow, we should have the same slope. It's not drastically changing. So if I do that, I can draw this curve. So that would be my solution curve, and you can tell as it starts off here, it's relatively a constant slope until it gets closer to the the x equals 0 axis, and then the slope starts to change, and we try to keep the line parallel to that slope, and then the solution is going to gradually go to 0. So I can look at this, and I can tell my boss that as x gets larger, the solution to our differential equation is going to be 0. Alright, so our solution will tend towards 0. Alright, so this is a graphical solution to a first order ordinary differential equation. Let's do some more examples. So here is my differential equation, okay, and I'm telling it that I'm taking the derivative of y with respect to x. I'm telling Maple that y depends on x. I'm also telling this y also depends on x. So this is my differential equation. Now here's my direction field, and you can see in here that it's kind of changing, right? Yeah, alright. And again, it depends on the initial condition you pick. So what command actually produced this? This is the command that actually produced it. Okay, I got my derivative, I've got my independent variable here, I've got my x range, and I got my y range. Okay, so how about we do some initial conditions. Now Maple will also plot solution curves for you. These black lines here are solution curves for specific initial conditions. So we have to know how to give Maple these initial conditions. So here is the command that I used to get these initial conditions. So what you have to do is, after your ranges of x and y, you put a comma, and then you got to put a list of points with square brackets in here. So the first initial condition is x equals 0, y equals 0.2, which I think is there, and x equals 0, y equals 0.4, which is I think is there, x equals 0, y equals 0.6, which and x equals 0, y is equal to 0.7, or 0.8 actually, it's right there. And then you can follow this, and you can see how all these solutions come together and eventually look like they're merging into the same solution. Looks like it's sinusoidal in nature. So again, what you can do is you can look at this graph and tell if your initial condition is somewhere here out in this area of the graph. You can tell your boss that as x gets larger, the solution turns into a sinusoidal solution. And you can try to make a prediction. So if x equals 6, you can say that the solution is probably going to be around 0.5, maybe a little larger. Alright, so I've showed you. Okay, so looks like PowerPoint is changed. This needs to be a capital E for this command to work. Sorry about that. Alright, how do we get this to do this in Maple? There's technically two ways. You're using the with and the capital DE tools command, and then using DE plot to write out the command. The other one is have Maple do the work for you, or most of the work for you. And to do that, if you go up to the toolbar and click Tools, then Tasks, then Browse, and then you look for differential equations, then ODE, then direction fields, and you click that. And then up will come another window, and then you want to click Insert Default Content, and that's going to insert a template into the worksheet that you're in Maple. And what you have to do is change the information in that worksheet. So you'd have to put in the differential equation that you want to solve, okay? You'll have to change your x and y ranges for x and y to fit your problem, and also change the initial conditions to fit your problem. And then once you've got that done, if you go to the top of the screen, you should see this button with 3 exclamation points. If you click that, that'll rerun the whole window and produce the direction curve you're looking for, or slope field you're looking for. Well, we will work on several of these when we get to class. I will have some printouts of direction fields where you can draw the solutions by hand, and we'll work some more in class so that you guys can figure out how to solve some of these direction fields, or use direction fields to solve your differential equations. Alright, looking forward to seeing you in class.